All right, so remember Q and K are very similar. Q is products to their coefficients over reactants to their coefficients at any time, while K is the products to their coefficient over the reactants to their coefficients at equilibrium. So the only difference is at what point in time you're talking about in terms of the reaction. And we remember that Q will always go towards K, right? Your reaction will always go towards equilibrium. And so if you know Q and K, you can predict in which direction the reaction will go. So we can have kind of two instances, right? We can have if Q is less than K, and then if Q is greater than K. And of course, if Q is equal to K, that means you're at equilibrium and the reaction's not going anywhere. And so if your Q is less than K, let's think about what needs to happen, right? Q is always going to go towards K. And so if your Q is less than K, your Q needs to grow. The numerical value of Q needs to get bigger. And remember, it's products over reactants. And so if your Q needs to get bigger, that means your numerator needs to grow and your denominator needs to shrink. So the amount of products, it needs to increase and the amount of reactants needs to decrease. And so if you're going towards the product sides, or if you're increasing the amount of products, decreasing the amount of reactants, you're going towards products. And then conversely, if your Q is greater than K, your Q must become K, and so the numerical value of Q must shrink. And again, Q is products over reactants. And so this number needs to get smaller. In order for this number to get smaller, your numerator has to shrink, so your amount of products has to decrease, and your denominator has to grow, so your amount of reactants has to increase. If you're increasing the amount of reactants and decreasing the amount of product, you're going towards reactants. So shouldn't be too difficult to figure this kind of stuff out. So let's take a look at an example. So here we have 2NO plus Cl2 going to 2NoCl. And we'll say that the current concentrations are equal to this, right? So your current concentration of NO is equal to 0.05 molar. That of Cl2 is equal to 0.015 molar. And then that of NoCl is equal to 0.500 molar. And then we'll also tell you that your K, so your equilibrium constant, is equal to 4,600. And so K is something you can look up in textbooks and stuff like that, reference manuals. And so the question we're asking is, will the reaction go to products or reactants? Products or reactants. And so we remember that Q is always going to go towards K. We have our value of K, and then we have the information necessary to find the value of Q. So let's go ahead and find the value of Q. Remember, it's products to the exponents of their coefficients over reactants to the exponents of their coefficients. And so then we're going to plug some stuff in here. So the products here, if we take a look back at a reaction, is NoCl. And there's a 2 in front of it, so it's going to be squared. So it's the concentration of NoCl squared over the reactants, which is the NO squared times the Cl2. And then we're just going to take these numbers and plug them in. So our concentration of NO is 0.05. Our concentration of Cl2 is 0.015. and then our concentration of NOCl is 0.5. So we're going to go ahead and plug all those things in. So we've got 0.5 squared divided by 0.05 squared times 0.0155. And then when you plug all those numbers in, you get a value of 6,450. So Q is equal to 6,450. K is equal to 4,600. And so we can say that our Q is greater than our K. So in order for Q to go towards K to become K, we need Q to shrink, and since it's products over reactants, we need the amount of products to go down and the amount of reactants to go up, and so it's going to go towards the reactants. So there's an example of that. Check out 13.3 in your book as well for another good example.